starting it now.
Alright.
Alright, so the stream should be live. Hello everyone, we're going to give about 1 more minute to stragglers and then we're going to begin. While I get set up. You should see a stream feed here in just a second. Good? Okay.
I have audio also, so we're all good.
Okay. Oh, it yanked one of my options out. So the videos may not work. They were working before, but they may not be working today because it took my mirroring option away. All right, we're gonna find out. All right, welcome everybody. Thank you for coming back for day 3. I wanted to start off if anybody had questions, if they looked over anything, if anything was confusing after you've gotten a chance to digest a little bit. I know I'm throwing a lot of information at you pretty quick. So was there any questions anybody had from yesterday or day 1? Okay. If there's no questions, then we're going to go forward. So today we're going to be talking about RDS, or Relational Database Service. So what is RDS? I have a video. I'm hoping this works. We're going to find out. It did work earlier, but that is apparently meant nothing. So.
Isn't it great when your application and its database work together like a finely tuned machine? The application's out front, making your customers happy, and the database is just behind the scenes, giving the application great performance, durably storing your customers' data, and always being available. But your database is getting bigger all the time, and you're always taking on more. Running databases means a lot of repetitive management work. It has to be done, but it doesn't directly help your customers. How will you stay ahead of growth so that your databases don't become the bottleneck? And how will you be ready for disaster? Fortunately, there's a way to avoid the undifferentiated heavy lifting and get ahead of the complexity and risk. Amazon Relational Database Service, or Amazon RDS, is a managed service that makes it easy to set up, operate, and scale a relational database in the cloud. You can choose from the new Amazon Aurora engine, MySQL, PostgreSQL, Oracle Database, or Microsoft SQL Server. And AWS even keeps up with patching them for you. You can keep using existing tools and applications. With Amazon RDS, there's no need to buy, rack, and stack hardware, and no need to install software. Just click and go, and new databases will be made available while you do more important stuff. And there's no need to stress out about capacity planning. Scaling up your databases becomes easy because you can get more capacity and horsepower whenever you need it. You can even scale out your database by adding read replicas. Giving your database high availability is simple with Amazon RDS. Just choose to run in multiple availability zones. If disaster strikes, RDS will fail over to a standby. And you can replicate your data to another AWS region, near or far, with the push of a button. Amazon RDS even lets you run replicas in other regions. Backing up and restoring your database can be a big headache. But Amazon RDS makes it easy. You get automated backups that let you recover to a point in time you choose. You also get a simple way to take consistent and durable snapshots on demand and keep them as long as you want. What will you do with all the time that using Amazon RDS frees up? You'll create innovative ways to serve your customers. Amazon RDS makes it easy and inexpensive to experiment. Clone your databases as many times as you like, and discard the experiments when you're done. You pay only for the resources you use. Amazon RDS, the easy way to set up, operate, and scale a relational database in the cloud. Visit the AWS Management Console and launch your first database instance today.
Alright, I apologize for everybody watching on the stream. The video did not come through. So I will, like I said, I'll send out the links for those. Also, after the whole presentation on Friday, I'll be sending out the slides, which have the links to the videos as well. We're going to skip the other videos so that we're at least consistent with both the stream and in person. Okay, so RDS, Relational Database Service. It's an AWS managed implementation of common relational databases. Some of the supported databases are Oracle, SQL Server, MySQL, Postgres, and AWS Aurora. AWS has their own implementation of an RDS called Aurora. It's built on either MySQL or Postgres, and it's more of a clusterized RDS implementation. I'm not going to go really any further than that because you don't need to know more than that for the developer exam, but it's good information to know. You can take automated backups, so your RDS will be snapshotted for you so that you can do a point-in-time recovery. You can also take manual snapshots as well. So if you've made a change or anything, you want to take a snapshot yourself, that is available to you. So RDS is not covered super heavily in the developer exam, or at least not to my experience. There are other topics pertaining to RDS that we're not going to cover this time, such as multiple AZ failover and read replicas. But please be aware that those are covered pretty heavily if you do the architect or sysops or any other of the other exams. You will get tested on some of the other material. So this by no means is a fully comprehensive covering of RDS, but this should give you enough to get you through your developer exam. Questions? Yes?
How are they licensed?
So the question is, how are they licensed? When you spin up an instance, you get a choice of which one you want to use. So if you wanted to use SQL Server or Oracle, that cost is built into the pricing of your RDS. So they handle the licensing for you and wrap that into the cost of the RDS instance.
So we don't technically have a SQL Server license then?
They manage the licenses for the RDS. Amazon handles them for the RDSs. Now, if you wanted to bring your own license, I'm not sure that you can do that through RDS, but I know that if you wanted to spin up an EC2 and host your own instance, you could bring your own license and manage it that way. In reality, what they're doing with RDS is you pick an instance type, which means they're putting an instance out there for you, but they're doing the management of the RDS itself. Any other questions? Okay. We're going to move on to Dynamo. That's supposed to say Dynamo. This DynamoDB. So what is DynamoDB? DynamoDB is a fully managed NoSQL solution provided by Amazon. Amazon built this. Pay close attention to Dynamo. This is a pretty heavily covered topic in the developer exam. This is one of the most highly covered topics for the developer exam. So pay close attention. In most cases, you can get single-digit millisecond responses from a Dynamo table. It's replicated across 3 zones. Now you have 2 ways of retrieving data. You can do a query or a scan. Queries. This is searches the table or index for records based on the partition and or sort key. Or a scan, which reads all the records of the table and then applies a filter. This is very slow. It is highly recommended that you run queries over scans if you can help it. Data consistency. You can use 2 different types of checks to ensure data consistency. So why might we want to do this? If a user is writing a record, now we have 3 zones that this is hosted in. Let's switch over to the camera, actually. Can you make sure that switches, please?
Sure will.
All right, so we have 3 different areas that our data is being hosted in. And we don't choose which one we point to. When we make our write, it manages that under the hood. So say that I'm pointed to here, and I do a new write. And I update product price to equal $10 for product ID 5. Okay? So I'm saying I want to update product ID is 5, that's priced at $10. I write here, and then it needs to replicate to the other hosted zones. During that time, however, somebody else might come in and do a write of product price, and they might put it at $20 for prod 5. So now we have a collision. Now we have an issue in which I don't know if the data that I was trying to transform was what I was expecting to do. Which one hits first and which one gets taken first. This is where the data consistency comes in. We can use atomic counters or conditional writes. So an atomic counter will increment or decrement a value based on independent of writes. So it might, if you have an atomic counter, it might say, oh, I triggered 1 write. And if I did this again, I'll trigger 2 writes. It's not necessarily accounting for other people making changes, but it is logging the number of times that a write has happened. Or you can use conditional writes. And a conditional write says if, and let's say that the price and ID, so 5, and it was $5. So it originally was 5. I tried to change it to 10. Somebody else tried to change it to 20. With a conditional write, I'm going to say if the price is $5, then make my change. So if I'm updating it and it's $5, then make my change. But if it was 20, that write wouldn't take place because that's not the condition in which we wanted to trigger that write for. Does everybody follow?
Does it give you an error?
I think it comes back and it states that the write wasn't successful. Don't quote me on that, but I believe so. So conditional writes checks for a condition before updating a record to ensure that it was not changed to something unknown prior to the new write. All right, indexes. There are 2 types of indexes on a Dynamo table. They are local secondary indexes and global secondary indexes. And this is very important. So a local secondary index. This is an index on a Dynamo table that must be created during the time of creation. So when you create that table, you need to create this local secondary index. Let's backpedal just a second. With a Dynamo DB, you don't host a database, you host tables. So your level, like your unit that you're working with, is a table, and you create your tables. They're not hosted within a database. So everything is in terms of tables. For local secondary indexes, you must have the same partition key as the table, but can have a different sort key. So when I create a table, I might have a partition key of ID and a sort key of date time. If I wanted to create a local secondary index, then I would have to have ID as my partition key for my local secondary index as well. But I could change my date time, my sort key, to product color if I wanted. And I don't know that you'd want to do that, but that one can change, but your partition key must remain the same. It uses the throughput of the table. So we're gonna cycle back to throughput here in a minute because there's calculations that you need to understand of how to do that. But a high-level covering is when you create a DynamoDB table, you need to provision a certain amount of data throughput that you expect. Now this can be changed on the fly, but it's kind of like how wide do you want to open that pipeline for data, and the wider the pipeline, the more you pay. Well, yes, question?
Can you click on your video, or back on your presentation, because it doesn't look like it's the web, the stream is catching up with the video where you're at, so it's like it's paused on RDS.
Okay.
I don't know if you can.
Let me scroll through a little bit.
It's like it didn't. It's back to your presentation, but the presentation doesn't know that you've changed the page.
Okay. Okay, so I switched to the camera real quick to try to fix that.
Okay. So maybe it'll kick back in. It'll take about 15 seconds for me to find out.
Sorry for the technical difficulties, everybody. Sometimes the stuff can be finicky.
Okay, just flash to the camera now back, but it's still on RDS. It's not on Dynamo.
Okay. Alright, so it should kick in here in a second.
There it goes.
Is it on the Dynamo?
Yes, we are.
Okay.
Thank you.
Okay, so local secondary indexes. Okay, for a local secondary index, and thank you for pointing that out. For a local secondary index, you can only have 5 per table. So when you create the table, you provide a partition key and or a sort key. Or you have to have a partition key, but you can choose to have a sort key. Your indexes, same kind of thing for your local, but you can only have 5 of your local secondary indexes per table. Then you have global secondary indexes. And global secondary indexes can be created during or after table creation. They can have different partition keys and or different sort keys. So unlike the local secondary index, where I had to keep my partition key the same, I can have a different partition key and a different sort key for my global secondary index. So I might want to have my partition key now be product size and my sort key be product color. And I could do that. Probably wouldn't be a good query, but you can change the different keys. It does, however, require additional throughput for the index specifically. And you can have a max of 5 per table. So remember that only 5 local secondary indexes and 5 global secondary indexes can be on any given table. So when you create your Dynamo tables, make sure you're planning what you want to do. A little side note as well, there is no linking like outer joins or any joins like you would have in a relational database. NoSQL, each table is independent. So keep that in mind as well. Your queries are scoped to just what's in your table. Questions? Okay. Limits. So Dynamo limits. You can have 256 tables per region. Now this is a soft limit. This is one of those that you can contact Amazon and request more, and they will increase your limit. Your partition key length. The minimum is 1 byte, and the maximum is 2,048 bytes. Your sort key length. Your minimum is 1 byte, and your maximum is 1024 bytes. Your item size. The max item size. Now this includes your attribute names and your values, so that entire item, the max size can only be 400 kilobytes. Okay, so we're cycling over to provisioned throughput. So provisioned throughput is us estimating how much bandwidth, how much data we expect our Dynamo table to have to handle. And this is in both reads and writes. So if I'm creating a Dynamo table, I need to have an idea of how many read units I need to have. Now, if we look here, read units, there's 2 different types of reads that you can make against a DynamoDB table. These are strongly consistent or eventually consistent. Strongly consistent reads is 1 read per second up to 4 kilobytes. So 1 read for a strongly consistent read unit is measured in seconds, and it's measured in units of 4 kilobytes. And then the 2 reads per second up to 4 for the eventually consistent, the bullet points in the wrong place. Writes. 1 write per second is up to 1 kilobyte. So a write unit is 1 kilobyte per second. And we're going to talk about how to calculate these. You need to know how to calculate these for your exam. So if you flip in your packets towards the back, I think it's your third to last page, you should have a page that says Dynamo throughput calculations. Okay. So we are going to cover how do we calculate a read unit, how do we calculate a write unit. So for read units, we're going to round up the size of our item being entered to the nearest increment of 4 kilobytes. For strongly consistent, and you should see on your sheet, and also here on the slides, the formula here. For strongly consistent is your size rounded up to the nearest increment of 4 kilobytes divided by 4 kilobytes times the number of items. So 4 kilobytes is 1 strongly consistent read per second. For your eventually consistent, that is the size of your item rounded to the nearest increment of 4 kilobytes divided by 4 kilobytes times the number of items, and then you divide that by 2. So that is how you calculate your eventually consistent reads per second. And don't worry, we're going to go through a few of these. I know it's a little bit confusing right now, but hang with me. Your writes. Your write units are the number of items per second times the size of the item rounded to the nearest kilobyte. So, we have an example here. You should also see this one in your sheets. You have an application that requires 20 items at 6 kilobytes per second to be read using eventually consistency. How many read units will be needed? So in order to figure out how many eventually consistent reads we're going to need, we are going to take the 6 kilobytes, rounded up to the nearest increment of 4. So when we round up, the nearest increment of 4 would be 8. And then we're going to divide 8 kilobytes by 4. So we're going to have 2 read units. Then we're going to multiply that by the 20 items we expect per second to get us 40 read units. And now that 40 read units would be what you needed to provision if you wanted a strongly consistent read. So on your table, if you're expecting this kind of throughput for your reads, then you would assign your read units to be 40 read units. Then to get the eventual consistency, you would now divide that by 2 to get 20 read units. So this is 20 read units per second. Does everybody follow? All right, we have a write example. So you have a sensor that needs to record 120 items per minute, each at 1.75 kilobytes. How many read units will be required for this operation? So let's convert the number of items a minute to seconds, because your throughput is measured in seconds. So 120 items divided by 120 items per minute divided by 60 seconds gives us 2 items per second. Then we round the item size. Then we round the item size to the nearest whole increment of 1 kilobyte. So we have 1.75. We need to round up to the nearest increment, and that's 2. And then we multiply the size of the item and the number of units per second. So we're going to multiply 2 by 2 and get 4. So we need 4 write units per second to record the calculations from this sensor. Does everybody follow? I know this probably feels kind of like a math class, but you do need to know how to convert these. So now I'm going to give you guys a few minutes, and you get to calculate your own. So look at the formulas that you've been given, and take a crack at the problems that you've been given.
So what do you do with the information once you calculate all this stuff?
So in the console, there is a throughput tab, and you will need to tell the Dynamo table how much throughput it needs to expect. So based on the demand, we are setting that pipeline of how much to expect per second. And you set this is an attribute on the table that you will set. Does that make sense? Yeah.
So which one is more faster and reliable? So is it Dynamo or the RDS?
So the question was, which is a faster tool, RDS or Dynamo?
Mm-hmm.
Dynamo. You're getting single millisecond responses. So Dynamo is extremely fast, but it is a little bit more managed, and it is a NoSQL. You're not going out and you're not doing links, you're not doing any of that, but Dynamo is extremely fast.
How about the cost?
Dynamo's cost is pretty cheap. I have a table, and I think it's like 1 write unit and 1 read unit per second, and it's $2 a month. It's very good on cost, and something kind of cool about Dynamo, and this kind of jumps ahead a little bit, is since you can adjust your Dynamo throughput on the fly, you can actually use something like Lambda to detect how much data you're going to need and scale your throughput. So you can use Lambda expressions, or you could go in and you could change your provisioned throughput on the fly. So that's another way that you can manage cost as well. An example with that might be if you know that you have most of your data coming in during the daytime, but very little at night, you could scale up a little bit more in the day and then scale back down towards the night. So.
And then is there a corollary to SQL? They have their own proprietary query language, or what?
So
Document search language, or?
yeah, this would be more closely related to. So let me repeat the question. How close is a query related to and Dynamo towards as it would be in an RDS or a normal relational database? Correct? No, this would be much more like querying a Mongo or another NoSQL database where you need to know how to retrieve that record.
Do they have their own query language, or
is
there a Mongo document search language or table search language, query language?
I've done very little with the actual querying component of it. The way it was is like I had to structure a document of the key value pairs that I was looking for, and then it would retrieve based on my criteria the key value pairs that I was looking for in a document. So it's like I constructed a document, I would provide the partition key with the ID that I wanted, and maybe another filter criteria of something else that was part of the item, and then I would submit that. So I was providing a document, and that was the best of my understanding. Dynamo itself is still fairly new to me as well. I know how to do the calculations, I know the data about it, and it's something I've been getting hands-on with a little bit more recently. How's everybody doing with the calculations? Anybody need more time?
I haven't started those, taking notes.
Dog ate mine.
All right, I'll give like 2 more minutes, and then let's talk them through.
Can I borrow someone's abacus? Gotta have one.
When it says the nearest increment of 4K, does that mean the nearest above?
So So the question was, is when you round to the nearest, do you round up? Yes, always round up.
You round up every time, even though your number might be less than half?
Yes, because you're provisioning throughput, so if you would round down, you wouldn't have enough throughput for that object.
Rounded up.
Sorry, I should have been a little more clear on that.
Yeah, so I didn't round on this one. Save it now.
All right, does anybody have an answer for me on number 1?
120? 120.
100 and
Good. So the answer for number 1 is 120 read units.
second. Yes.
Yes, per second. Can somebody tell me how you got that?
You follow the formula.
That's a good answer.
Plug and chug.
All right.
5K, go to 8K,
So
divide by
all right,
4.
Tell me how to do this.
8 divided by 4 times 60.
A little bit slower. All right, so we got 60 items, 5K per. So our formula is size rounded to the nearest increment of 4. So 5 would go up to 8 KB. That would be divided by 4 KB, which is going to give us 2. And then we're going to multiply the 2 by...
Number of items?
Huh?
By the number of items?
Yep.
60?
Yeah, sorry. I read the wrong thing. 60. 120. Make sense?
That's what I got too.
Cool.
I rounded up instead of down.
Yeah, I should have clarified that. Think in terms of throughput. You're wanting X amount of data to go through. If you round up a little bit, that's okay. If you round it down, you don't have enough provisioned. All right, number 2. What'd you guys get?
150.
150? All right. So what are we looking for here? The first one was strong consistency. This one is eventually consistent. Okay, so we have 100 items. And we have at 12 kilobytes. So 12, that's a increment of 4. So we're going to divide by 4 KB. And that's going to give us 3. And then we're going to do 3 times the number of items, which is going to give us 300. And since it's eventually consistent, we're going to divide by 2 to get 150. Make sense?
Gold star.
Good? Okay. Did I say a question?
No, I was giving you a thumbs up.
Okay.
Sorry.
All right. I know these sound kind of annoying, but these are a pretty heavy topic on the exam. These are very important to know how to calculate. Okay. So writes under the right section. I guess it's number 3 on that one. On the slides, I have it differently on the paper, but it should be the same question. And yes, can somebody tell me the answer for number 3 or under the right section, number 1?
200.
So the answer is 200, and we have 200 items at 0.45 kV, 0.45 kV. So how do we get the answer for this? We round the 0.45 up to an increment of 1, so we have 1 kb, and we do 200 times 1 kb, which gets us 200. Everybody follow? Mm-hmm. Writes overall are pretty simple. Just make sure that when you're reading your questions that you know exactly what they're asking for. Are they asking for write? Are they asking for eventually consistent reads? Or are they asking for strongly consistent reads? All right, last one. Number 4. Somebody give me the answer.
80.
80. All right. So we have 10 items. Every per 250 milliseconds. So now we have a time difference because this is milliseconds, not seconds. And this is 2 kb. So, you want to tell me how you did that?
I must have done it wrong, huh?
You have the right answer.
So basically, you had to convert your 250 milliseconds into a second. So that's 1/4 of a second.
Mm-hmm. So if we know that 250 ms times 4 equals 1 second, then our 10 items. So the number of items per second is what we're calculating, and the 10 times 4 is going to equal 40. So we have 40 items per second at 2 kilobytes each. So then do the 40 times 2, 80. Good? Okay. I highly encourage you guys to go out, find other problems for these, make up your own, use the formula, but practice these until it's second nature. All right. Any questions on Dynamo? I encourage you guys to go out there, you read the FAQ pages, you read up on Dynamo. Dynamo is a very important topic for the developer exam. All right, if there are no questions on Dynamo.
I got a quick question.
Yes?
Did you talk about the exceeded throughput?
Did I skip something? I missed it on my slides. You're right, though. Okay, so on the study guide, we covered this. I missed this on the slides. I apologize. Exceeded throughput. So let's go jump back in the Dynamo section. Exceeded throughput is an exception that you can get from a Dynamo table if you do not have enough throughput calculated for what you're trying to do. So in the example of rounding down instead of up for your size, you would probably get a provision throughput exceeded exception. And that's where the amount of data you're trying to write or read is greater than what you have provisioned. I believe it will still process them, but it will throttle what you get, and you're still going to get that exception. So if you get that, you need to scale up, or you need to readjust your throughput to meet your needs. Does that make sense? Thank you. Is there anything else?
So with that, because you talked about using the lambda to check what your throughput is, so can you change your throughput every minute?
Yeah, you can trigger changes in your throughput.
At any?
I don't know of any time restrictions.
Okay. Good.
Any other questions? Okay. Like I said, make sure that you go out there, read up on Dynamo, and that you have a good, strong covering, or a good, strong knowledge of Dynamo. Okay, SNS. SNS stands for Simple Notification Service. It's kind of a fun little service, but it is a service used to push messages to subscribers. So the components of an SNS are topics, and topics are channels for sending messages to subscribers. Keep in mind the name of a topic must be unique. You have subscribers. Subscribers are users or services registered to a topic to receive messages or notifications. Available protocols that you can send a message through to a subscriber, or that a subscriber can register that they want to receive their message in that format would be HTTP, HTTPS, email, email JSON, SQS, which is another service we'll talk about, or an application. You can integrate, so the application one, this can be integrated with like Google or Apple or other notification services for mobile push notifications. And then we have messages. Messages are data that you would send to subscribers. So a topic is the thread in which a subscriber would subscribe to. So I might be a subscriber and I would subscribe to the EC2 machines created topic. And I might have in my EC2 bootstrap script, my user data, I might have those trigger a message on my SNS stating that the bootstrap has run successfully. And I've done this before where I trigger a message on my SNS topic and then I receive an email stating that my bootstrap script ran successfully. Messages can be customized by protocol type, and the components of a message are the message ID, which is a unique ID per message, the message itself, which is the value of the message, a signature, which is a base 64 encoded signature of the message and associated metadata, the signature version, which is a version of the SNS signature used, signing cert URL is the URL to the certificate, that's the wrong word, used to sign the message. The subject, this is optional, highly recommended. I've had issues before with delivery of messages that didn't contain a subject. This is the subject of the message being sent. A timestamp of the notification. The topic, ARN. So you'll see ARNs a lot, and I actually haven't covered this. ARN stands for Amazon Resource Name. These are used throughout AWS to specify a service and something within a service on your account. So usually it's like ARN, colon, account, colon, service, colon, name. So in this case, it would probably be along the lines of ARN, colon, my account number, colon, SNS, colon, EC2, user data. And that would be my topic name. Amazon resource name, and this is for the specified topic. The type of notification, and an unsubscribe URL. And this is a URL that users can use to unsubscribe from a topic. Also, keep in mind that when you add a subscriber to a topic, they will receive an email or they'll receive a message in which they need to confirm that they have actually subscribed to that topic. So you can't just add a bunch of people and expect that you're just going to start sending a bunch of emails out to them. They actually have to confirm that subscription, and then they can also use that unsubscribe URL to remove themselves from that subscription.
Is there a scope for the subscription? Do you have to include people? Like only these people can get the subscription? Or how does that work?
So the question was, is there a scope to the subscription? When you create a topic, you get the ability to add subscribers. And then from there, the topic will deliver that message to any of the subscribers on that topic.
Can we create groups like email groups?
The question was, can you create groups like email groups? That's kind of what your topic is the topic is that group in which you're going to send the message to. And you can have several if you wanted different groups you're going to email out to. The EC2 thing was just an example. So a real world example might be that you would use SNS to notify you if something has become available or if maybe an alarm goes off through CloudWatch. CloudWatch is outside of the scope of this exam, but if you would have something that would trigger an alarm, it might email you stating your alarm is going off. So you've been in violation of CPU percentage for 3 periods of 5 minutes. That might be a real world example of it notifies you when there's an issue or it notifies you when there's a success. For instance, CloudFormation, I believe you can set up SNS notifications to let you know when your stat comes up. So SNS is a pretty simple service, but it's really handy. It helps notify you or different applications of things that are going on. One other real quick example would be you can use this with Lambda, and I know I talked about Lambda a little bit. I'm not talking about it as part of this class because it's not part of your exam, but if you guys get a chance, go out there and mess with Lambda. It's serverless computer operations, and you can set events to trigger small pieces of code to go off. One of the triggers is an SNS. So you could, once your EC2 came up, you might have, and you publish a message from that. Then if you have your trigger on your Lambda set correctly, you could have it maybe write information into a database for you about that instance. So this is a great tie-between service with some of the others that will let you do some really remarkable things. Any other questions? Okay, we've got 10 minutes left. Let's see if we can cover SQS. Okay, SQS, Simple Queue Service. This is a programmatic queue used to temporarily collect messages that will be processed by workers. You use this to create decoupled architectures. Guys, pay attention to that word decoupled. If they're asking about anything decoupled, think SQS. Make that your first thought. Decoupled SQS. This is the first service created by Amazon. Messages can be delivered multiple times and have in no specific order. Now there's two different types of queues. I've only seen the standard queue in the exam, but this may have changed. There's also now a FIFO queue, which will guarantee the order of the messages. So keep that in mind. And keep in mind also is Amazon changes so fast and so often that this is kind of hard to keep up with. Even the people writing the tests struggle because Amazon is releasing new features all the time. The max message size is 256 kilobytes, and this is billed in 64 kilobit chunks. Just a little fun fact, but the first million requests for SQS are free. And after that, per million is 50 cents. I mean, so this kind of gives an idea of how cheap this is. Lambda is another one that's very cheap. It's first million are free, and I think after that it's a couple cents. Up to maybe the max, a couple bucks. Pay attention to the different timeouts and different times that you can have, these features. So visibility timeout. This is the time that a message is made visible to the queue so that other workers cannot pick it up. So actually, let me draw one real quick. Switch over to the camera. A queue. We're just going to explain this. SQS. So this is our SQS queue. And we have some sort of application dropping records in here. So let's just say, and we got a person here, and they are dropping records into this queue. These are getting backed up, and they're waiting for worker nodes. In this case, we're going to use EC2s. And our worker nodes are going to process the items in this queue. So when one becomes available, it's going to go in here, and it's going to say, give me this item. It's going to work it through, and when it's done, it's going to knock it out of the queue, and they're going to grab the next one. So while this one's processing, maybe the other one here grabs the next item, and it works this queue down by availability. The reason this is good decoupled architecture is because if your EC2s went down and you did not have this, if you were just going through an ELB, you could lose traffic. But in a queue, they're getting collected, and then when your workers come back available, they can start picking right back up from that queue again. Another nice feature about this would be that for some reason, maybe I need to change this layer. Then I can swap my layer out with a different set, maybe EC2s, maybe even Lambdas, or containers, whatever. Then I point it back to my queue. I haven't lost any of my messages, and it doesn't affect how they're coming in. It just affects what's processing them. But the visibility timeout is the amount of time that a message is made invisible to the queue so that workers can't pick it up. So when when number one picks up this record, it's not out of the queue until he says, I'm done. But it is made invisible so that number two doesn't go over here and say, oh, I need to pick this one up and double process it. Does everybody follow? The minimum amount of time for the visibility timeout is 0. The default is 30 seconds. And the maximum is 12 hours. Now there's the change message visibility command, or change message visibility call that you can make as well, API call. And this is the action used to specify a new timeout, if you need to extend the time a message is invisible from the queue. So in our example where record 1 picked up that item, say that it's noticing that it's not going to be done with this record in time. It can use the change message visibility to extend the amount of time that it is hidden from the queue. So it's kind of saying, hey, give me an extension on time. I'm still working on this. Don't become available into the queue for other workers to grab. Polling. There is 2 types of polling. So SQS is a poll service. You have short polling, which is the immediate polling of the queue even if the queue is empty, and long polling. Long polling is a delayed time between polling the queue to reduce costs. So if my queue is empty and with short polling, I would say, hey, do I have an item? 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 No. I keep getting no. I'm burning up cycles. This is going to cost me more because I keep asking for this record. But if I enable long polling, I can set a delay. And I can go up to 20 seconds. And I can say, hey, every 20 seconds, do I have a record? No. Do I have a record? No. And a response is not returned until a message arrives in the queue or the long poll times out. So go, wait, do I have an item? Yes, I do. And then it's going to run through that item. Message retention. How long a message remains unprocessed in the queue. So how long can I have an item in my queue stay in the queue before it leaves my queue? The minimum is 1 minute. The default is 4 days. And the maximum is 14 days. So, for instance, and this is part of the decoupled architecture, is if I had a long weekend, I had a 3-day weekend, and I had people submitting images to my queue that they wanted watermarked. And they can wait, it's going to be email delivery. Would I have lost my images if after my long weekend, my worker nodes died? My workers died, the queue is not getting processed. I haven't changed my default. Would I have lost the requests that I had?
No.
No, because the default's 4 days. So if that would have been the case with a load balancer or on the instances themselves, those requests would have been lost. We wouldn't have been able to go back and grab those requests. The maximum is also 14 days. So you can leave an item up to 14 days in the queue. When they are unprocessed, when you've not processed an item and it falls out of the message retention time or the unsuccessful attempts, it can go into what's called a dead letter queue. And this is like an unsuccessful queue that messages from other queues can be sent to for analysis. So why did this message fail? And then finally, you can do what's called fanning out. SQS and SNS can be used together to fan out by using SNS to deliver to multiple SQS queues. So let's switch over to the camera real quick. This is the last thing we're talking about. So SNS is a push service, and SQS is a pull service. So say that we have 3 queues that we want to work through, okay? And they may have different workers that are processing them. Don't necessarily have to, but they may. Okay, so our workers, and they're getting items from the queue. I may say, okay, a user has dropped an image in an S3 bucket. And this is going to use I'm going to trigger an SNS notification. And now I will let my SNS notification deliver the information in my queue. So this might be the location in S3 where my image is. So I might have the path to my image in my S3 that I use SNS to process, and then I put that information in the messages in my queue. Now my workers start knocking my queue down. So let's say that this is a resize queue. This is a meme generator, and this is a thumbnail processor. Each are doing something with that source image. So they don't want to modify that image, but they're going to grab it and they're going to do something. Usually what they would do is they would put it in another bucket as a destination. So they're going to dump into different destinations once they're done. So the worker pushes the new changed item into those buckets. But they get the information about that image. Worker pulls that, goes to S3, gets the object in S3 based on the path that's in the message, works it through, puts it into the new destination, removes the item. And each queue would do this, but it's triggered all by one SNS message. Everybody follow? Any questions? Okay, then that's it for today. If there's no other further questions, we'll pick back up with Elastic Beanstalk tomorrow. Thanks, guys.
Thank you.
Thanks.